Hello viewers, you are welcome to another ArcGIS tutorial. I want to thank all our subscribers for always keeping in touch with us, and for those that are new on this channel, please subscribe in order for you to get notification whenever we upload a new video. In today's tutorial, we shall be estimating the K factor of RUSLE model for soil loss, which is the soil erodibility. In our last tutorial, a soil map was produced, and this same soil map is what we shall be estimating the K factor from. As we know that K factor of RUSLE is one of the K factor of RUSLE, which is the soil erodibility, is one of the factors responsible for soil loss. And in today's tutorial, we will use Williams equation in estimating our K factor. So Williams equation, we have F sand, we have K factor to be equals to F sand multiplied by F clay multiplied by F organic multiplied by F multiplied by 0.1317. Now the function of the sand, clay, organic, carbon and silt is what gives us our K factor, where our M sand is proportion of sand content, M silt is the proportion of silt content, M clay is the proportion of clay content, and organic carbon is the amount of the organic carbon content of the layer. And using this equation, we shall use our field calculator on ArcGIS to estimate this. So here is the map produced in the last video. If you open the attribute data of the map produced, we have our dump soil, which is the code of the soil. This is the soil name, though there are other fields which I have deleted from the attribute data. There are fields that are not required, so I have to remove them. In order for us to estimate from the equation, we have F sand, F organic carbon, silt, and that of clay. Don't forget, on the previous one of our previous video, we showed how to download the file data, the file soil data on file portal. The folder that was downloaded comprises of some Word and Excel files, and one of the Excel files here contains the percentage of soil, clay, subsoil, pH 2, organic carbon, and so on and so forth. And with all these, we have that for the topsoil and we have for the subsoil. And here are the code for the which also represent our dump soil on the other attribute data. Now, for this Williams equation, all I need is my sand, clay, silt, and organic carbon of the top soil and not the subsoil. So we need sand, clay, organic carbon, and silt of the top soil. So here are the two columns that will be required. Four columns: 1, 2, 3, and the organic carbon, which is the fourth one. So I'm going to extract just this information alongside with my code. Don't forget, these are the various soil type for the world, for the digital soil map. So these are the various soil type we have, and in this soil type we have almost 500 soil type with their composition, with the percentage of their composition. Now on my map, I have, on my watershed, I have almost 364 soil type. So with this soil information I'm going to extract out, I'll bring that to my table here. I need to add the data that I've extracted, which is, don't forget, you have to save it in a CSV format. So here I have soil info use. So this is what I want to use, and I want to open so that you see some of the. Now I have the soil unit symbol, which is the same thing as my dump soil on the database for the map produced, and the sand percentage, silt percentage, clay percentage, and topsoil, organic carbon percentage. I have more than the number of soil that are present on my own watershed. All I need is just to match the table together. So I will join. I want to join and relate the table. I said my dump soil is the same thing as my I'm using this other one. So it's the same thing as my soil unit symbol. Validate the joining. Okay, now we have now we have so we have okay, now we have the percentage of sand, topsoil, and so on. Let me remove this column. It's of no use, or turn it off. Better still, turn it off. So I have this information. Now with this data, I need to create a field for these parameters they are calculating, the F sand, organic, clay, and silt. So create your hard field. Which is our F sand, so I want to add another field, which is our F clay, F clay, we had another field, which is our F organic carbon, and the last field we are adding is the earth silt. So we are calculating for these three parameters, and this is how we go about it using our field calculator on ArcGIS. So the formula here okay, now go to field calculator. Let's calculate. You have to be very careful with bracket opening here in order to have the right answer. So the equation says, so open the bracket for the equation first, is 0.2 plus, I'm going to open another bracket here, plus 0.3 multiply by exponential. In my exponential, I'm going to open another bracket again. So that's where I want to work. Exponential minus 0.256 multiply by m sound then multiply by another open bracket, multiply by 1 minus m silt divided by 100. I think now we should have the correct value. I guess something is wrong with this. Okay, let's go back and let's run what we have done so far. Want to run in again. Okay, so this is what we have for so this is our F sum. Now we calculate that of the clay. The clay is equals to m silt. So you open the bracket M seat, which is this, multiply by, divided by, then another bracket will now be open to be closed, divided by M clay plus M clay plus M seat. Then at the end of everything, you now multiply by. So you use this symbol to to raise to power 0.3. So you use that symbol to give it a. So let's load. Now we have our clay content. Then we go to our organic carbon using the formula. So for organic carbon, we have, you clear this. For organic carbon, we have, you open the bracket. Always be careful with your bracket. Open the bracket, 1 minus, then you open another bracket, 1 minus 0.0. Okay, we are going to have two brackets there. So I have 0.0256 multiplied by organic carbon. So after the close of the bracket, you now have divided by. It's going to be after divided by. Now a bracket open here as well, which is organic carbon multiplied by organic carbon plus the exponential of exponential of 3.72 minus 3.72 minus, I'll put another one in bracket, minus 2.95 multiply by the organic carbon again. I think that's all for this. We're good to go. So we have for organic carbon, and the last is our M set. So go into your fit calculator, you clear this, open brackets, one minus, open another bracket here, and we're having like two brackets here, 1 minus 0.7 multiply by another bracket open there, multiply by 1 minus M sound divided by 100. So that will be after two brackets. Now we now have our division, and from there you open another bracket. After that you open another bracket, which will now be 1. No, the bracket will be 2 this time around. 2 to now be 1 minus m sound divided by 100 100, and immediately after we had plus exponential of exponential of minus 5.51 plus 22.9 multiply by, open another bracket, which will now be our 1 minus m sound divided by 100. I think we're good to go with this. So now we have calculated our 4 parameters. So we're going to introduce another table for our K factor. So introduce another, I had another field which you can now tag as a K factor. Okay, so this K factor here, now we have the formula for the K factor here, which is equals to, our K is equals to going to our fit calculator. K is equals to F sound, which is what we have calculated, sound multiplied by F clay multiplied by F organic multiplied by F set multiplied by 0.1317. Okay, now this is our K factor. This is our K factor. Can now maximize. Now that we have the K factor, we now produce our soil erodibility map by converting this into raster. Don't forget, this is what, okay, instead I make use of what I'm having, as I can reclassify this going to my properties using the K factor instead of my other value which I use. So this is how it quantifies. So I have this. You can see. So God. All we need to do now is to produce our soil erodibility map by estimating the. Now that we have done the estimation, you go to your arc toolbox, and go to your conversion tools to raster, then polygon to raster. I want to convert because the data downloaded from file soil is a polygon, a vector format. So we now want to change what we have to raster format. Now I input my feature, which is my then my this field value, that is where we are going to input our K factor. We input our K factor, then I would like to give it a name and have it in my folder. So now I have my, let me off this. Now I have my K factor, my erodibility map. Just click, I'm going to symbol to give it a color ramp. So this is the soil erodibility map. Thanks for watching. If you find this video helpful, don't forget to give it a thumbs up. Thank you very much for watching.